Remind everybody, we've heard the term gravitational waves or ripples in space-time. That's surely accurate, but I don't know that it helps. So how can you dig into that and unpack what's going on?
Yeah, so I think one of the ways we can think about that is it's very tempting to look out into space and think of empty space as a number of things that aren't true. Space isn't empty. Space doesn't do nothing. It actually has many, many dynamical properties, things that, like, it can curve, it can ripple, it can tear. And so that's really the wavy part of space-time. And the idea is that when we have objects that are massive, so they should have gravity, and if they just...
When you say massive, you don't mean a brick or a stone. You're talking about black holes.
Well, bricks and stones would do the same thing, except it would be just a much, much smaller effect.
And harder to measure.
Way harder.
So our
to measure.
threshold is for what? I mean, our measurement threshold today.
Our measurement thresholds today are not even ordinary stars like our own sun.
Couldn't measure that.
No. So if we're looking for waves from these kinds of objects, there are more things like neutron stars and black holes.
So dense objects in the universe
objects,
where
exactly.
gravity is saying something.
Yeah, so objects that have so much gravity packed into a small volume that really the space around those objects is very bent.
Okay.
Have those objects tried Ozempic?
Oh. How do we end up doing a commercial for a pharmaceutical company and we're not getting paid for
We're
it?
helping the black holes slim down a little bit. They're very dense. They're causing waves and gravity.
Actually,
we don't want them to slim down.
For their work, but actually, isn't Hawking radiation a kind of Ozempic for black holes?
Yeah, it'll help them evaporate.
Yeah, so we got a little mechanism. So tell everybody about Hawking radiation.
So Hawking radiation, it comes about from the quantum mechanical properties of black holes. So the idea is that in quantum mechanics, we have a phenomenon where particles and antiparticles can be formed out of photons, and then they can crash together and become photons again. And Hawking radiation
So it's energy to matter back to energy.
Yes.
So E equals MC squared would prescribe how much of that is happening in any moment. Okay.
Right. And Hawking
E
radiation...
on one side, M on the other side, so we good.
And then C is speed of light?
Speed of light squared.
Yeah.
Squared, yeah.
Okay.
And so this is a phenomenon by which, as you create these particles, some of that energy can get radiated away. Where does that energy come from? It comes from the properties of the gravitational properties of the black hole. What happens?
So you're stealing matter out of the black hole and thereby taking away some of its gravity.
Yes.
Okay.
And
And